All application pods restarted at once after a secret update, causing a database connection storm and 500 errors. The root cause? The database password was injected as an environment variable, which Kubernetes never updates in running pods. When the pods finally restarted, they all hit the database at the same time. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Kubernetes ConfigMap secrets. ConfigMaps and Secrets are Kubernetes API objects that decouple configuration from container images. ConfigMaps hold non-sensitive data like feature flags and URLs. Secrets hold sensitive data like passwords and tokens. Both are stored in etcetera and can be injected into pods as environment variables or mounted as files. Here's how they look in YAML. A config map uses the data field for plain text. A secret uses data for base 64 encoded values, but you can use string data for plain text that gets encoded automatically. Both are namespaced resources. Both config maps and secrets are stored in etcetera. The API server is the only component that talks to etcetera. By default, secrets are stored in plain text. Envelope encryption must be explicitly enabled via the encryption provider config flag on the API server. This encryption configuration enables ESCBC encryption for secrets at rest. The identity provider is a fallback for reading old unencrypted data. Without this, a compromised etcetera backup exposes all secrets. Config maps and secrets can be consumed as environment variables or volume mounts. Env Vars are set at pod creation and never update. Volume mounts support live rotation, but the kubelet syncs changes every seconds. SubPath mounts do not auto-update. This pod injects the entire config map and secret as environment variables. The values are snapshots taken at pod creation. Updating the secret does not update the running pod's environment. This pod mounts the config map and secret as volumes. The files will update when the source changes within the kubelet sync interval. Note the default mode, 440 for secure file permissions. Avoid subpath for rotating secrets. RBAC is the real security boundary for secrets. Use a dedicated service account per workload, disable auto-mounting of tokens, and restrict access to specific secret names using resource names in the role. Never grant the list, verb on secrets. This RBAC setup creates a dedicated service account with auto-mount service account token. False, a role that allows get on only 2 specific secrets and a role binding to tie them together. This prevents enumeration and limits exposure. For mature organizations, native secrets are insufficient. External secret stores like Vault or Oz Secrets Manager provide automatic rotation and audit logs. The Secret Store CSI driver mounts external secrets directly into pods without storing them in etcetera. This configuration uses the Secret Store CSI driver to mount a secret from Vault. The Secret Provider class defines the provider and path. The pod mounts the volume, and the secret is never stored in etcetera. When consuming config maps, choose volume mounts for dynamic configuration that needs live updates. Env Vars are fine for startup-only values. Mixing both for the same data source leads to confusion. This pod mounts a config map as a volume. After updating the config map, the file at etc/config/port, txt, will update within the kubelet sync interval. Your app can watch for file changes and reconfigure without restarting. Kubernetes secrets are base 64 encoded, not encrypted. Base 64 is reversible with a single command. Anyone with access to etcetera or backups can decode every secret. Enable envelope encryption at rest before creating any secrets. At scale, native secrets break due to lack of automatic rotation and audit. External secrets operator sync secrets from a vault into native Kubernetes secrets, enabling rotation without pod restarts. But remember to layer defenses. Encrypt etcetera, lock down RBAC, and use IAM. This external secret syncs a password from AWS Secrets Manager into a native Kubernetes secret every hour. When the password rotates in AWS, the Kubernetes secret is updated automatically, and mounted volumes pick up the change. This is the same issue we highlighted at the start. Here's exactly why that happened. The database password was injected as an environment variable, which is a snapshot at pod creation. When the secret was updated, the pods kept using the old password. When they were eventually restarted manually, all pods restarted simultaneously, overwhelming the database connection pool. The fix involved 4 changes. Switch from Env Var to volume mount so the file updates live. Implement application-level file watching to reload credentials. Use a rolling restart strategy with max unavailable. 1. To avoid simultaneous restarts, and configure the connection pool to retry with exponential backoff. SubPath mounts do not auto-update when the source secret changes. The file is a snapshot at mount time. Avoid subpath for any secret that rotates. This is the exact pattern that caused the incident. The secret keyref injects the password as an environment variable, which is a snapshot. When the secret changes, the pod still has the old value until restart. Base 64 is not encryption. The value C3VWZX, JZZW, and YZXQ equals decodes to supersecret with a single command. Always enable envelope encryption and restrict RBAC. The encryption configuration resource shown in the article uses APA-server config K8ZO/V1, which is available since Kubernetes v1.13. In v1.29+, the identity provider is deprecated in favor of ESCM or KMS for better security. Always check your cluster version and prefer KMS with a cloud KMS provider for production. The article mentions ConfigMaps and Secrets are stored in etc., but large or frequently updated ones can degrade API server performance. Use immutable, true on ConfigMaps/secrets that never change after creation. This skips watch overhead and reduces etc. load. The article warns about large secrets inflating etc., but doesn't mention the hard limit. Secrets and config maps are limited to 1 MB in size, etc's default max request size. For larger data, e.g., TLS certificates with intermediate chains, split across multiple secrets or use an external store. Monitor etc. server requests total for request failures. When debugging configuration issues, start by verifying the secret exists in the correct namespace. Check if the config is injected as Env Var or volume mount. For volume mounts, wait up to 60 seconds for kubelet sync. Inspect file permissions with kubectl exec. Let's run through some common interview questions. What is the difference between ConfigMap and Secret? ConfigMap stores non-sensitive data. Secret stores sensitive data with base 64 encoding and optional encryption. Is base 64 encoding secure? No, it's reversible. Security comes from RBAC and envelope encryption. How do you rotate a secret without restarting pods? Mount the secret as a volume and have the app reread the file. And a few frequently asked questions. What is the difference between ConfigMap and Secret? ConfigMap store non-sensitive data. Secret stores sensitive data with base 64 encoding and optional encryption. Is base 64 encryption? No, it's a serialization format. Anyone with read access can decode. How to rotate a secret without restart. Mount as volume, app rereads file. Use rolling restart for critical rotations. To recap, ConfigMaps and Secrets decouple config from images, but base 64 is not encryption. Use volume mounts for rotating secrets, enforce RBAC with dedicated service accounts, and always test your rotation runbook. Ready to go deeper? Up next, Kubernetes stateful sets, then Kubernetes HPA, then Kubernetes monitoring with Prometheus. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.